Hello and welcome back to Math Class in Session. Today, trigonometry problems. 1. Two ships leave a harbor, the first at noon and the second half an hour later. The first ship sails on a course of 30 degrees at a speed of 20 kilometers an hour. The second ship sails on a course of 160 at a speed of 15 kilometers an hour. A, determine the distance between the two ships at 2:30 that afternoon. 14:30 means 2:30 in the afternoon. B, find the radar bearing from the first ship to the second ship. Solution. A. First, we must draw a diagram, and that's the hard part. Then we have to put the situation on it. To do this, we'll need to find the distances that the two ships traveled during that period of time that they left, the first one at noon, the second one at 12:30, and 2:30 that afternoon, which is 14:30. And to do that, to find those distances, to figure out such things, we can use this little aid. Distance is speed times time. So we'll make use of this, and we'll make use of the paragraph to draw a diagram, the hardest part. Now, I've done it all in one go here. There it is. But let's just check it for correctness. Two ships leave a harbor, the first at noon, the second at 12:30. The first ship sails on a course of 030. Well, this is north, and this is 30 degrees to the right of north. And so our first ship is heading on a course of 030. There it is, our first ship. Now, where did I get the 50? Well, the first left at noon, and we're interested at 2:30. That's 2.5 hours. So the time for the first ship is 2.5 hours, and the first ship sails at 20 kilometers an hour. So it's 2.5 times 20. Which is 50 kilometers. So that's how we got that distance. Similarly now for the second ship. The second ship sails on a course of 160. So again, we start at north and count out to 160. Well, that's 90, and 70 more makes 160. So I put a 70 here. And the distance that this second ship traveled along this line on a bearing of 160 is, once again, the second ship left at 12:30, and we're measuring at 2:30. That's 2 hours later. So the time for the second ship is 2 hours, and the speed for the second ship is 15 kilometers an hour. So speed times time is 15 times 2 hours. So that's 30. That's why it says 30 here for the second ship. And what we need to do is figure out this distance, D I called it. And we notice that it's a side angle side situation. We have side, angle, side in this big triangle here. And so this is a simple cosine law application. I firmly believe that drawing this diagram is the hardest part. Doing the cosine law application is just d squared equals 50 squared plus 30 squared minus 2 times 50 times 30 times the cosine of 130. Do it on a calculator. Don't forget to take the square root, and we can conclude our answer. Therefore, the ships are 73 kilometers apart at 2:30 in the afternoon. Now, there was a second part to this question. Suppose that ship 2 had a medical emergency at 2:30 in the afternoon and radioed to the first ship and said, please send your medevac helicopter to us. We have a need for it. So the helicopter takes off from the first ship and has to fly 73 kilometers to the second ship. But the question is, what direction? Because, well, You can't see 73 kilometers out across the ocean, especially if it's foggy or dark. So the helicopter has to know in what direction to travel. That's why we need to figure out the radar bearing. So I've set it up like this. We're going to find theta and beta, and then we'll find the heading. So I just copied the diagram over with the 50 and the 30 and the 73 kilometers and all the other information. And now we can get theta very easily because it's a sine law application. Sine theta over 30 equals sine 130 over 73. So this is an application of a sine law. Multiply the 30 over. Take a look at this. Sin steps across the equal sign and becomes inverse sin. You could have turned this into a decimal or left it like that and typed it into a calculator. And we know what theta is. Theta is 18.3. So to get beta, well, we can go 30 subtract 18.3. Why 30? Because this is 60. And so together, these two have to make up 30. The part that beta is 30 degrees take away theta. So beta is 30 take away 18.3. So beta is 11.7. We also know this is 30 because look at this Z. There's 30 here. So there must be 30 here. Theta is taking up 18.3, so beta is taking up the remainder. Now the question is, since directions are measured from north, we have to measure from north all the way around to there. And that will be 180 degrees plus beta. So it's 180 plus 11.7. We can do that in our head. That's 191.7. So that's the direction that the helicopter flies. Let's do a second question. Two observers are separated by 2 kilometers along an east-west line, and there's a hot air balloon up in the air between them. Observer A sights the balloon at 30 degrees angle of elevation, and this observer B sights the balloon at 20 degrees. Determine the height of the balloon. So here's our diagram. Observer A is 30 degrees, observer B 20 degrees. There's the height of the balloon, and these two observers are separated by 2 kilometers. How high is the balloon? Well, I've transferred this diagram. I brought it forward, and we need a side of a triangle of which H is a member. If we're going to find H, it has to be a member of a triangle, of which we know at least one other side. And this problem is that this side here, AB, which is 2 kilometers long, is not a side of a triangle of which H is a member. H is a member of this little triangle on the right. H is a member of this little triangle on the left. But H is not a member of the larger triangle. So what we'll do is we'll use sine law to figure out either AC or CB. Then we'll have a side of a triangle of which H is a member. We can start by saying, how big is this angle? Why? Because we're working within the large triangle. We know this, that in the large triangle, this is 30 degrees and this is 20 degrees, and we can figure out this by saying 180 subtract 50. Well, subtract 30, subtract 20. And that turns out to be 130 degrees. So now we can get either AC or CB. Let's find, say, side B. Now, side B is opposite B, so this would be B here. And we can find that side by saying B over sine 20 equals 2 over sine 130. And using our calculator, multiplying by sine 20, multiplying 2 times sine 20 divided by sine 130, we get our b value. And now we have a side of a triangle of which h is a member. We can just use SOHCAHTOA in this right triangle. Don't use a sine law again. You can just use SOHCAHTOA because it's a right triangle. So find h. Sine 30 is opposite over hypotenuse. Now in this case, opposite happens to be an h, but that's opposite. So sine 30 is opposite over hypotenuse. And so h is multiply that over and do it on a calculator. And we found h. I'd like you to notice something about this problem. And this is what I'd like you to notice. Given this triangle, we could have gotten the area of the triangle because it's 1/2 times the base times the height. We worked hard to find the height. So if the question was find the area of a triangle, we could do it this way. By first finding the height and then saying 1/2 times the base times the height that we just found. Let's go to a second question here. From a point on a level road, the measure of the angle between the road and the top of a mountain is 6 degrees. And if you drive closer by 4 kilometers to the mountain and get out of your car and measure again, well, you have to look up a little more steeply. It's 8 degrees. Find the height of the mountain. So as usual, we draw a diagram. We're looking for the height of the mountain, and we have a point where the angle of elevation is 6, and we have a closer point where the angle of elevation will be more than that, 8, and the separation here is 4 kilometers. So once again, we need a side of a triangle of which h is a member. Now, h is a member of this triangle. H is a member of this larger triangle. But 4 is not a member of either one of those triangles. So we have to get a side of a triangle of which h is a member. So notice how this side right here is shared by these two triangles. So we'll go after this guy. Let's call it x. I've just transferred the diagram forward. Let's get x first and then get h. Now we notice that because these two must add up to 180, this is 172 if this is 8. And all these have to add up to 180 as well, so this must be 2 if this is 172 and this is 6. So that we can add these angles in because we know that they have to add up to 180, both for the straight line and for the triangle. And now getting x is just x over sine 6 equals 4 over sine 2. Multiply both sides by sine 6. Take it on a calculator, and we know what x is. X is 12. And now we can get h using SOHCAHTOA. Sine 8 is opposite over hypotenuse.